first of a few units that coincide with the two courses. So this is one that you want to get a good start on, and you want to have a good understanding of, which leads you into probability. So you gotta make sure that you're asking questions if you're not 100% sure what's going on in it. Okay, so counting principles. The fundamental counting principle. If one task can be performed in A ways and another task can be performed in B ways, then both tasks can be performed in A times B ways. A series of tasks can be performed in A ways and B ways and C ways and so on. All these tasks can be performed in A, B, C ways. Or page 90, 4.1. For or situations, the fundamental counting principle does not apply. You have all of that's in A plus all of that's in B. Now in the last one, if they're mutually exclusive. If they're not, then you subtract. So there's a lot of gibberish there for you right now as I go through it quickly. So the best way for me to show you how this works is to show you examples and explain it as we go. Okay? So the first example that they use is Kim is choosing a new cell phone. She can choose the 300, the 400, or the 500 model in green, pink, indigo, orange, or taupe. Kim is also deciding whether or not to get a data plan for her phone. All right. So first thing that you need to know, every time you make a decision, you need a blank. And within that blank goes the number of decisions that are, or the number of choices that are possible. So for example, in this particular question, the first decision is your model. The second decision is color. And the third decision is your data plan. So this tells you how many ways. This is what we call the fundamental counting principle. So in the first blank, how many choices do I have for the model? I have 3 choices for the model. How many choices do I have for color? 5 choices for color. And then I have a choice. Do I get a data plan or do I not? So how many choices do I have there? 2. So the number of ways in which I can select one of these phones based on the model, the color, and whether or not I have a data plan, I multiply these all together, and there are 30 ways in which this can happen. Okay? So each blank represents a decision, and within the blank, you get the number of choices in that decision. Now, as we do the work in the pre-calculus, I'm going to show you how today to draw a proper tree diagram to represent this situation. Okay? And then we can count it by looking at the tree diagram. So the first thing is, the first decision I have to make is the model number, right? So I'm going to draw a tree diagram to do this. The branches will represent each decision that's being made. So I put at the end of the branches what the 3 decisions are. So I have a choice of a 300, a 400, or a 500 model. Fair enough? Yeah. Okay. Now, if I was doing probability, which we are not doing yet, and I don't know if we even get into it in this course, but we will eventually. I then put my probabilities on the branches here. So I have 1 and 3, 1 and 3, and 1 and 3 in this case. But that's for another day. Now, after I've decided on which phone, what's the next decision that I have to make? The colors. So I'm going to put my colors. How many colors are there? 5. Okay, well, give me the colors, please.
Green, pink, indigo, orange, and taupe.
Okay, and then I'm going to do the same for this model. Green, pink, indigo, orange, taupe. Oh, taupe is, that's a color to me.
It's like sand.
Green, pink, indigo, again another color. Okay, so there I have. So if I were just choosing a model and a color, how many choices would I have?
15,
How many?
18.
50. That's right. Each, you count the n branches,
Oh,
right? Because you have 5 choices for this, 5 choices for this, and 5 choices for that. So there's 15 choices that you can have. You can have the 300 in orange. You can have the 400 in taupe. You can have the 500 in indigo. Each one of those is a choice. So each branch represents a choice. And then from there, I have to put on data plan, no data plan, data plan, no data plan. Okay, so now when I'm adding 2 to each of these, how many choices do I have total? I have 30, right? So I have 30 choices with a data plan or no data plan. Okay, which is the same as what I had. Now a tree diagram is the most effective skill to use when you're doing this with probabilities. But for just doing actual choices and a number of ways of doing something, the fundamental counting principle is the easiest way to do things. Okay? All right, so far? All right, let's look at, yeah, go ahead.
I don't really get why it's not 18 and it's 15. Color one.
Because
there's 3 of each of those models, and then there's five different colors for each model, so 5 times 3.
Oh, okay, I get it now. Sorry.
all done. Okay? So far, so good, right? Okay, so the first in A says, how many different choices does Kim have altogether accounting for model, color, and data plan? So we did that, right? So there's 30 choices, okay? In B, it says, the store agent advises Kim not to choose the 300 model if she wants a data plan. Also, the 500 model is not available in indigo or taupe. How many choices does Kim have now? All right. Okay, so now what we have is we have restrictions on what's happening here. Okay? So, she says, do not choose the 300 model if she wants a data plan. Okay? So we want to find out how many choices are there then if she wants the data plan. So to do that, I'm going to set this up. Now this is where it gets a little bit sketchy. So I'm gonna lose you for a second and then I'll bring you all back so that you understand this in a minute, okay? Because there's an easier way to explain this. But so here's the thing. She says if she wants a data plan, she can't have the 300 model, right? So what I'm going to do is I'm going to say, all right, well, what is my one restriction? She has to have the data plan. So she's only got one choice. So if that's the case then, she only has one choice. How many choices does she have for the model number then? If she wants it, she has 2 choices, right? What are the 2 choices? The 400 or the 500. But then they put a restriction on the 500. What did they restrict to the 500? Indigo
And total.
and taupe aren't there, right? So now we got a lot of restrictions on this. So here's what I'm going to do then. Let's say then, let's change this a bit. Let's say that she chooses the 400 model. Okay? So she's got one choice. She wants a data plan, so she chose the 400 model. How many choices of color does she have then? She has 5 choices of color. So how many choices does she have total then? She has 5 total choices. Right? But she could select the 500 as well, right? So because she wants that data plan, 1, I want it to be the 500. So there's one choice there, but then how many choices of color does she have? 3 choices of color, right? Oh, that's a 3, not an 8. All right. So let's say that she has a data plan. How many choices does she have total then? She has 8 choices. Right? Okay. So it says, we've got that taken into account. But now I've got to talk about what? What happens if she does want a data plan? No? What happens if she doesn't want a data plan? So How many choices does she have now? So she has no plan. 1.
300. So, 1.
She can select what?
Oh, I
Any
guess.
side? She can select any model right now. Okay? But the 500 still has a bit of a restriction on it, doesn't it? Okay, so let's say if we have no restriction on color, that means it's the 300 or the 400. Do we agree? So that's 2 choices there, right? And then how many choices for color does she have? 5. So that's 10, correct? So far so good? Said it does get complicated. But I'll bring this back to you right away and I'll show you a different example that makes it easier. So she wants no data plan. We've already shown all the possible for the 300 and 400. So she has to have the 500 now. So how many choices does she have here?
3.
For color, she has only 3 choices, right? So now, when I add them all up, what do I get? 21 choices. She has 21 choices. So I have to show, first things first, the one most important thing that you need to know. When they ask you these questions on the exam, they're going to say, explain yourself. Okay? They're going to say, how many choices do you have and why? Your explanation is as simple as putting the squiggly brackets below and showing what your decisions were. That's the explanation. So as long as I write this out on below, that's the explanation that I need. That's all I need. So when you're doing it and you're making decisions, write in the blank or in the squiggly brackets below the blank what decisions you're choosing from. And that describes your explanation for it. Okay so far? All right? You multiply going across. And each separate case, you add to the other. Each separate case, you add to the other. Okay? Fairly straightforward so far. But I'll show you, this one was complicated. And they use their, if you look on page 91, they show you all the possibilities using the tree diagram. So the 300, you have 5 choices of color, but you have no plan in each case. So there's only 5 choices you can have for the 300, right? For the 400, you can have 5 choices of color, plus you can have a data plan or no data plan. So that makes how many? 10 there, right? And then the 500, you only have 3 choices of color, but data plan or no data plan, which is 6. So you add them all together and you still get to 21. So whatever you like and feel most comfortable in terms of your branches, your tree diagram, or doing the blanks is fine. But I think you're going to, once I start showing you a couple other examples, the blanks will make more sense to you. Okay, so far? Lexi, you've been wanting to ask a question. Perfect. I knew if I talked long enough, you'd forget your question. All right. Anybody else have anything you want to ask about this? Okay. Now this one had way more restrictions than what you're normally going to start with. So I'm going to show you an example today. Okay. How does this work and why? All right. I have 5 digits. I have the digits 1, 2, 3, 4, 5. Now they're metal and they're house numbers. So I'm going to stick them. I'm going to put them on the side of the house. I want to know how many 3-number house numbers I can get from these 5 digits. I want to know how many 3-number house numbers I can get from those 5 digits. Okay? I can't repeat them. Once I use one, I'm done. That's a whole different story. We'll talk about repeating later. All right? So, how many decisions do I have to make? How many? No. How many decisions do I have to make? How many digits do I need? 3.
Oh, 3.
I need 3 digits, right, from these 5. So how many decisions do I have to make? 3. So I start with my blanks. 1, 2, and 3. Okay? How many choices do I have in the first one? 5. I can pick any one of the 5 numbers, right? So now that I picked one, how many choices do I have for my second number? 4. Now I picked 2 numbers. How many choices do I have for my last number? 3. So how many 3-digit numbers can I get from 5 numbers? There's 60 ways in which I can do this. 3 decisions needed to be made. On the first one, I had a choice of 5. On the second, I had a choice of 4. And the third, I had a choice of 3. So there's 60 ways in which I can do that. Does that make sense? So far? Okay. So now how do I have fun with this and how do I change it? Alright, I only want even numbers. So I'm putting a restriction on it. I only want even numbers. So which of the 3 digits has a restriction on it? Pardon me?
135. No, it would just be the end number, wouldn't it?
Yes. Okay? You're dancing around it, sort of. Okay? It's exactly what he said. The end number, the last number. If I want the number to be even, I'm talking about a 3-digit number, which number has to be even? Which digit has to be even? The last one, right? So I go 3. Where's my restriction occur? On the last one, I'm going to make it even, right? So how many choices do I have for that guy? 2. All right. The only choices are 2 or 4. Now you picked one of them. Picked one, right? So how many choices do I have for this blank now? How many? 4. Now I picked 2 of the digits. How many choices do I have for that guy? 3. How many even numbers can I have out of 5 digits? 24. 24. How many odd numbers do I have?
36.
36. Be 36. Okay? Because exactly. You got 24 even numbers out of the 60. So how many odd ones would you have? 36. Let's see. Let's check and make sure. Odd number? How many choices do I have? My last digit's odd. 3. I pick one of those 3. How many do I have left here? 4. Pick one of those. How many here? 3. 4 times 3 times 3. 36. 36. Does that make sense? Okay? So let's have a little more fun with this. All right? I want an even number greater than 200. No, sorry, greater than 300. Greater than 300. So how many restrictions have I put on this? 2 restrictions, right? First of all, the last digit has to be what? Even. And the first digit would have to be 3 or greater, right? Right? So I got 2 restrictions. Now I got to say to myself, well, which one of those restrictions affects both? Because remember, I can only use the one number once, right? So which one of those numbers is going to have an impact on the first and the last digit? Which one? The 4. The 4 is, right? Because in order for the number to be greater than 200, it has to be, the first digit has to be a 3, a 4, or a 5. We all agree? And in order for it to be even, the last number has to be a 2 or a 4. So we have to set up our cases in this sense. All right? So let's do it this way. Let's make the last digit a 2. So I've only got one choice for it. How many choices do I have here for greater than 200?
So it's greater than 300.
Or greater than 300, my bad. Yeah, you're right. Greater than 300.
So could you actually do 3 there if it's greater than 300? Cause.
No.
But if it's 300.
No.
It's still greater
Yeah.
than 300.
I don't understand your question.
Well, why does it have to be the 4 and 5? You can still have a 3 there and have a 300.
Thanks, Campbell. All right. So it has to be greater than 300. How many choices do I have there now? I have 3 choices. What are they? What does this have to be? A 3, a 4, or a 5?
Well, you were communicating very with me for a minute there.
I don't know. How many people are in here? Approximately 22 people, and 21 of the 22 knew what I was saying. It's my problem. I'm communicating poorly. All right. I picked 2 numbers. How many do I have left here? 3 left. So, to begin with, if the last digit is a 2, then I have 9 choices for my other 2 blanks. Follow? Okay. Let's make that last digit a 4 now. So how many choices do I have for here to be greater than 300? How many choices right there, boys? What is it? 2. What are my 2 options? 3 or 5. So I picked a 3 or a 5. I picked a 4. How many choices do I have left for this guy? 3 numbers left. "15 ways in which I can make an even number greater than 200, greater than 300. Do we understand what I'm doing here now? So you need to, first of all, put down the number of blanks for the number of decisions you're going to make, and then work with your restriction immediately. Now you're not going to get into complicated ones like this just yet, but it's good for you to see this to see where we're going with this. Okay? And realistically, is it that complicated? Not really, is it? Okay? Alright. Now, there was one other aspect of this. So this is what we call a fundamental counting principle. Now, where you're going to see it is I've got 6 students in a class, and I want to seat them in a row of 3. How many ways can I do that? That's kind of the type of question that you're going to look at. And then what we do is we get into permutations and combinations, in which we'll discuss how many options are there. The one I like to use, and I won't use it right away, but I'll tell you, is the Lotto 649. What are the chances you win the Lotto 649?
Pretty slim.
Well said, Lexi. Well said. Pretty slim is your right on. What we'll find out when we do it mathematically, it's about a 1 in 14 million chance, approximately. So you're seeing there's a chance that you make worse. Yeah. Okay, page 91, example 2. This is another part that you got to. This ties into your last unit in a very minor way. From a standard deck of cards, how many possibilities are there of drawing a 2 or a face card? Okay. Now, is this mutually exclusive? Is there any way I can have 2 and a face card together? No. I can't have a 2. 2 is not considered a face card, right? All right. So these are what we consider mutually exclusive. So all you have to do then is find out the number of 2s and add it to the number of face cards in a deck. So how many 2s are in a deck? 4. How many face cards are there in a deck? 12. So there's 16. There's 16 ways in which I can get a 2 or a face card in a deck. Pretty straightforward, right? Okay. Questions about that? That's good. How about a spade or a queen? A spade or a queen? Well, is there one that works with both? Yeah. Is there a queen of spades? Yeah, there is. Okay, so now, these are not considered mutually exclusive. So what I gotta do is I gotta take the number of spades, add it to the number of queens, and I have to subtract the number that is a spade and a queen. Okay, so just take a look back on page 90. If the tasks are not mutually exclusive, meaning that they do have something in common, they involve a non-disjoint set. So a disjoint set means there's nothing in common. That's the top question, right? Then you take the number of C or D is equal to the number of C plus the number of D minus the number of C and D. Okay? So, how many spades are in a deck? How many?
There's all kinds of them.
How many spades? One suit.
Oh,
How many?
4. No,
No.
that's wrong. So I was thinking one.
Number of spades, 13. Agreed?
Yes.
How many queens are in a deck?
4.
4 queens. How many queens of spades are in the deck? 1. 16. 16 ways in which you can pick a spade or a queen in the deck. Got it? I don't know why you guys are so tired today.
It's like a Monday. It's a
You
Wednesday.
guys are awful.
It's a hump day.
What do you got for a test today? Anything?
Nothing.
Then why were you up so late?
Yeah, you can practice late.
Unbelievable. You guys are all sleeping. My girls are all sleeping. You're not
Yeah,
allowed to do it. No, you're doing pretty good considering.
I'm pretty handy. Up to 1.
Yeah. All right. One last thing I want to show you, page 94. I'm going to go through this chapter fairly quickly. I will give you lots of time to work on it, but I'm away for 2 days, possibly 3 next week. So, no, gosh, no. One is
I need
stupid
to train
training.
for 2 to 3 days.
Well, 2 of them are for training and 1 might be for volleyball. So.
Good, I'm gonna need help for it.
Okay. Introducing permutations and factorial notation. Okay, so the first thing I want you to understand, you have never seen this before, this is brand new to all of you, and that is this right here. Okay? N factorial, that's called factorial. It's very simple. What it means is I take every number starting at that point and I multiply it by every number less than it until you get to 1. So what is 4 factorial? It's a short way of saying 4 times 3 times 2 times 1. That's what that means. Now, take out your calculators, please. Okay, those of you with graphing calculators, turn your screen on, put the number 4 in. Everybody's done that? Okay, math, arrow over till you get to the probability, and about the 4th or 5th one is the exclamation mark. Sorry? Yeah.
Yeah, 4.
You okay?
Got it.
And then once you've done that, hit enter again, and it should give you
24.
24. Fancy. Okay. Anybody not have that? Anybody not see it? Not follow it? Put up your hand. Anybody else other than Kelsey? Okay, now, you may have that button on your calculator.
Oh, it was Friday. Oh, I think. Get drunk, maybe go for a car ride or something.
Below my power plant here, 400.
That's an extra 50 next to horsepower.
So,
Anybody else not see it on their calculator?
Can't see.
Yeah, you can. Okay, are we good?
Yeah.
All right, now, here's the thing. All right, there's, where people lose their mind over this is when I just use the n factorial to describe what has just happened. So I'm going to do this in a very simple way. Again, I started with 4. How do I go from 4 to 3?
Take away one.
I take away 1. How do I go from 4 to 2? And then 4 to 1? Take away 3. So I'm going to start right here with n. Now what's the next number smaller than n? And subtract 1. And then and subtract 2. And subtract 3. Okay? And that goes all the way down until I get to 1. And I multiply. That's what that means. Okay, so far? Right? Because this is going to get a little bit complicated for you. You're gonna ask all kinds of questions. So I'm trying to keep it as easy as possible. So what if I had this? And I wanted to expand it out now. So what's my first number? N plus 2. What's the next number smaller than n plus 2? N plus 1. And then n. And then, yeah, so then it goes all the way down. So to 1, right? So far so good? All I'm doing is subtracting 1 each time.
How do you know when you get to that one?
Because you're going to go 8, 7, 6, 5, 4, 3, 2, and hit 1. You're going to go 100, 99, 98, 97, 96, all the way down to 1. Your last number is always going to be 1.
Oh,
Yeah.
Yes.
oh, I think that's a number in there.
Yes. Okay, so next order of business. Just, again, I'm showing you things that are a couple days away. But if I show them to you now, they won't be new to you when we do it a couple days away, and it won't be as confusing. So what happens if I have this? I wanted to reduce that. First thing I want you to tell me, which is larger, n factorial or n plus 2 factorial? N plus 2. So I'm going to always take the larger of them and expand it until it matches up with the one below it.
What do you mean of them? Of the ends?
Of the two values, the one on the top and the one on the bottom. Okay? So we say that this one's larger, right? So I start with n plus 2. What's the next number below n plus 2? N plus 1. And then what's after n plus 1? N. So that's like that, right? Okay? So now, what am I left with? N plus 2 times n plus 1. Is everybody following me so far? I'm trying to make the complicated part. I'll show you the easy part in a second.
Oh.
Okay? So does everybody understand that?
Oh, sure.
Yeah, go ahead.
Can the bigger number be at the bottom?
Yes, it can. Yeah, it can. And then you would have 1 over n plus 2 times n plus 1. Good question. Okay? So far, so good? All right? Let's see it in an easier way. What if I said to you this? 9 factorial over 7 factorial. Without using a calculator, I said, okay, what is this? So which is the obvious larger number? So let's expand it. Expand it out. 9 times 8 times 7 times 6 times 5, which is 7 factorial, agreed? Okay, over 7 factorial. What am I left with? 9 times 8, which is 72. Okay? So I showed you the way in which it was more complicated with the letters, but that's all you're simply doing. So if I told you, if I asked you to do this, what's 100 factorial over 98 factorial? Without a calculator, I want you to solve that.
Or 99.
9900, okay? This is 100 times 99, right? Times 98 factorial over 98 factorial. Those cancel, right? What am I left with? 100 times 99, which is 9900. So you can do this simply without using the calculator. However, you do have the calculator with you. Problem?
Yeah.
What is it?
I put in brackets. Okay.
No. No need brackets for this unless there's more multiplication on the bottom. Okay, one last example and then you guys can work on 4.1 and 4.2. Page 94, a 6-digit code number uses the digits 1 through 6 exactly once. If the first code of the number is 3 and the last digit is 2, how many possibilities are there for the code number? Okay, so I need how many digit number? 6. So how many decisions do I have to make? 6. So I need 6 blanks. 6 just like that, right?
Don't even have 4 because,
Hold on.
okay,
Hold on, I still have a 6-digit number,
yeah.
right? The first number and the last number are held, right? What's the first number? So I only have a choice of 1 for it, right? And what's the last digit?
2.
A 2. So I only have a choice of 1 for it, right?
Yeah.
So, correct? Sam, why are you looking like that?
I don't know, I just don't understand why you put no 1 on top of 2.
Because I have 1 choice. Remember, these are the decisions, and the number that goes on top is how many choices I have for it. But it says in the question that it has to be a 3 in the first blank. So I only have a 1.
Can't just put 3 there, it has to be 3.
No.
You have 3 choices if it's a 3.
No,
That's how many choices you have.
On top is the number of choices I have. You done dropping the pen. Okay, so now I have my 2 restrictions on there. How many choices do I have for this number?
4.
So what's the answer to the question? 4 factorial, right? Or you multiplied it out, 24.
Why is it
4 times 3 times 2 times 1 is 4 factorial. Okay? So you can write them out as factorials instead of writing out 4 times 3 times 2 times 1. All right? You can write it as 4 factorial. Okay? Any questions so far? I do have one. I see the example 2. Let's look at example 2. Which is larger, top or bottom? Top is? Okay, I'm going to just switch this for 1 second. I want to do this. Nine times 8 factorial. How could I rewrite that with only one number? 9 factorial. Agreed. Does everybody see that? Right? Because 9 and then times 8, 7, 6, 5, 4, 3, 2, 1 is 9 factorial. Right? So, using that knowledge, what is the top actually? N plus 3 factorial. Very good. Okay, but we're going to expand the top part here, right? N plus 3, N plus 2. What's the next number smaller than N plus 2? N plus 1 factorial over N plus 1 factorial, and cancel, cancel. Yeah, because the factorial represents every number smaller than that. So it's canceling that. And that's actually a good point. If I had this, like that, right? That's like saying 4 times 3, 2 times 1 over 3 times 2 times 1, you agree? So that cancels, that's why it cancels out the factorial. So I'm like the 4, does that make sense? Okay. All right. And the last one, these are the harder ones that people find, which is the exact same question I just did, except now it's equal to 30 and I have to solve for n. So let's have a look at this. This is how the question started. Like that, right? And when I reduced these, the top and the bottom, what was I reduced to?
You want to add one from the top,
Yeah, and then I canceled them, and what was I left with?
and then 2.
Yes. All right. Put your pens down for 1 second. What does this mean? Say again. It is an equation, absolutely. But what am I looking for? How do I solve for n here? I could, yeah, but I want you to think this through. I want you to think this through. It's even simpler than that. We are going to multiply n plus 3 by n plus 2, factor it, do the whole thing. But it's simpler than that. Can somebody tell me what n is right now?
No,
What is it?
3.
N is 3. How do you know it's 3?
Because 6 times 5 is 3.
He's absolutely right. Now, what does this mean right here? What are 2 consecutive numbers that I multiply together to get 30? What are 2 consecutive numbers that I multiply together to get 30? Well, what are they? 6 times 5. Right? So if that is 6 times 5, then what does that mean n has to be? N has to be 3. Okay? That's well done. So now, multiply this out by FOIL. N squared plus 5n plus 6 equals 30. Right? Get it equal to 0. N squared plus 5n minus 24 equals 0. Factor it. 2 blanks. Factors of n squared. N. Factors of minus 24 that add to give me 5. Negative 3 and plus 8. So n is equal to 3 and negative 8. And when you're talking about factorials, the smallest possible number you can have is 1. You can't have anything smaller than that, therefore you have to get rid of it. Now this is another lesson for you. We've talked about this in the past. When you take the x through, you're getting rid of what we call an extraneous root. This is a possible solution. You need to show that, but you have to x it out as part of your answer. If you don't, you'll lose a half a mark. Okay? So the correct answer was n equals 3. Now, if you had just said, well, that's 6 times 5, n equals 3, you could still get that right. But you'd lose the half mark for not showing the negative 8.
So how is it going to do that? Or we have to do it this long?
Now, that's only on the exam. That's only on the exam. You have to show that. On your test, you'll have to show it just so you're used to it. But during your work, you don't have to show that. Okay? And they won't do it in their answers in the back of the book. All right. You have the rest of today to do 4-1 and 4-2. Okay?
So when you're factoring and you find your a to negative 3,
Yeah.
how do you write it out? Like not that way, like before, and how do you write it out without using the brackets? Like you just say 3 plus 3.
About doing the brackets?
Yeah, like
Well, I know that 6 times 5 is equal to 30, right? So, what do I add to 3 to get 6? 3. What do I add 2 to get 6? To get 5. 3. That means I add 3. So then I would write it like this. N equals 3. Okay? But it's,
I mean, I can explain this.
We'll come back. to that. Okay, work on that. 4.1.
Oh, so just the messing me right up here already.
Blanks, put blanks in, right?
Yep, your letters.
And just redo it. I had those done.
You're done.